Payloads are an important part of the exploitation of the target system. While an exploit can abuse a vulnerability, it's the payload that is needed for the next step. Payloads carry functionality for greater access into the target. Let's look at the Metasploit framework payloads. The Metasploit framework includes many types of payloads with specific code for a variety of platforms. There are quite a few required because the functionality needed for payloads is dependent on the context in which they're used, as well as the target platform on which they have to execute. Payloads in the Metasploit framework are also modules just like every other piece of functionality in the framework. This means that they get updated and expanded with framework updates. You can also develop your own payloads. There are two types of payloads. Singles are self-contained payloads that contain all the functionality needed in one package. Stagers and stages are a method of breaking up the payload functionality. A stager is code that is launched on the target platform. It then grabs additional payload code to launch and use called stages. We'll talk more about these two types next. Payloads are organized by the platforms on which they run and the functionality the payload provides. The name of the payload indicates how it's used. They are also searchable, just as exploits are. Payloads also have configurable options as well. Most of the options are needed to define specific functionality of the payload depending on what it does. We'll look at a few more common options later. There are two types of payloads. Some documentation may list three, but two of them are interrelated. I count those two as just one. Payloads that contain all of the code needed and run independent of other payloads are known as singles. These typically provide one very specific function. For example, a simple single payload might open a forward connection to a command shell on the target system. Stagers, on the other hand, have more specific functionality in establishing the network connection with the target system. They're very small and allow for larger components to be loaded later. Stages are those larger components then used to execute code for functionality on the target system. It could also be opening a command shell on the target. So, why the need for two types of payloads? Singles work on vulnerabilities that can accept a larger payload size. Stagers can be used where size of the payload matters with the vulnerability on the target. Stagers contain mostly the code for the network connection, so they're smaller. Stagers can also be more reliable in that there are multiple options, especially when the target system may have the no execute bit set. Stages can be larger since the stager did the heavy lifting and memory allocation needed for the stage to be loaded. Payloads are also named in a similar manner to exploits. They're organized into a directory hierarchy based on the platform, processor architecture type, and then a name. The platform is a simplified name of the target system. Examples include Windows, Linux, OS X for Mac OS X, Java, which has platform-independent code, multi for multiple platforms, and then interpreters for PHP, Python, and Ruby code. The processor architecture is very specific because most of the payload code is written in assembly language and is therefore very specific to the processor on the target system. Here, examples can include x86 for 32-bit Intel-based processors, x64 for 64-bit Intel-based processors, ARM-LE for mobile and embedded devices, PPC for PowerPC processors, and PPC64 for 64-bit PowerPC processors. There are also others. There is one exception to the rule. Windows payloads for 32-bit architectures do not have an x86 architecture specified in their full path. There's one for the 64-bit x64 payloads, and I suspect it's a legacy thing. The name of the payload contains information about its use. If you see bind in the name, then Metasploit will create a forward connection to the target. A reverse in the name indicates a reverse connection from the target back to you. Other names include shell for an interactive command shell on the target system, PowerShell for PowerShell on a Windows target, add user to create a new user account, exec for executing a command, say to speak a command to the user of the target system, message box to place a window with a message on the screen, download_exec, which downloads code from a remote system and executes that code. Meterpreter is a special payload from the Metasploit project. We'll talk more about that one in more detail later on. For now, it's a very capable utility that not only provides an interactive session with a target, but a suite of tools for post-exploitation activities. The payload naming scheme also incorporates the two types of payloads. Single payloads incorporate the connection and functionality into one name. For example, shell_bind_TCP is a single because the functionality for the network connection and the shell is wrapped up in one payload represented by the single name used. Stagers and stages contain a separation between the stager and that stage, which is represented with two names needed when selecting a payload. Here you can see a stager and stage payload that provides the same functionality as the previous single payload. The difference is in the name used. Bind_TCP is the stager. Shell is the stage. Here's another example. The shell stage is the name, but the stager now uses a reverse connection. Let's look at the commands you will use to work with payloads. The show payloads command will list every payload, including the singles as well as the stagers and stages. If you have an exploit selected for use, the show payloads command will only show payloads that are applicable to the target system. You can also search. As we've shown before, there are several options to the search command. Use search-h to find those. The documentation doesn't list the payload type, but it works. You can also use the path parameter with payload as well. Once you have a payload in mind, use the info command to see a description and more details. You can also examine any options the payload has. Assuming you are working within the context of a selected exploit, you can choose the payload to attach as well. Use the set payload command with the full path of the payload. Show options will also list all the options for the exploit as well as the payload. They are separated in the output, so you can tell the difference in options. Payloads that use a reverse connection need the lhost option for the local IP of your penetration testing workstation to connect to. Since this doesn't change too often, you can make that a global setting with the setg command.